All right, good morning. So today we're going to be starting our new unit, which is on sequences and series. So we're going to start with arithmetic versus geometric sequences. Some of this will be reviewed for you from Algebra 1, so we're just going to start for today. So remember, you can pause the video at any point, do problems on your own, take notes in your notebook, but I'm going to just walk you through everything. So to start, just following the notes that are on my computer, but I'm going to do everything on the board. So the notes are posted online for you as well. All right, so here we go. So we're just looking for, find the next three terms in the sequence of numbers that are there. So this is just gonna be your warm up. So just looking for patterns in numbers. So if we look at the first one, we know that obviously there's a pattern here. So for each one, we are actually counting up by a certain number. And you know that that number here is going to be plus 20. So you're adding 20 each time to each number. So if I wanted the next three terms in this sequence of numbers, I would have 94, 114, and then 134, counting up by 20 each time. Looking at the second one over here, we're looking for the patterns in the numbers for this one. And if you look at first, you're starting off by counting by 3. But then you're still not counting by 3 for the next one. So notice the next one actually goes up to 5. And then from there, you notice it's going up again, so plus 7. So what do you think the next number would be that you're going to be adding? And notice that that would be 9, right? Because you're adding odd numbers every time. So your next number, continuing with that, would be 24. Well, how do you get from 24 to the next number then? So instead of adding 9, you're now going to add the next odd number, which is 11. So if you add 11 to 24, we have 35. And then in order to get from 35 to the next number, instead of adding 11, you're now going to be adding the next odd number, which is 13. So adding 13 to 35, you have 48. The third one over here, noticing you are adding the same number every single time, and that number is plus 100 each time. So our next three numbers in this group of numbers would be 409, 509, and then 609. Number 4, looking for this pattern over here. From 37 to 46, noticing that you're adding 9. From 46 to 55, you're also adding 9. And then from 55 to 64, you're also adding 9. So noticing that the next number in this sequence of numbers would be 73, 82, and then 9 would be 91. All right, so that's our warm up. So now let's look at the next piece. So the next piece, let me just move my, there we go. So looking at your notes, we're talking about sequences versus series. So a sequence is just an ordered list of numbers. So just like we did for Arduino, we had a list of numbers there. That is called a sequence. The sum of the terms in the sequence, so if you decided to add all of those numbers up, it is called a series. There are different ways to represent series when we talk about questions like this. You could actually tell me what the series is, which would be the sum, or you can represent it as a sum of a sequence. So interesting. And we'll get there later on. So each number that we're talking about in the list of numbers is called a term. We have different types of lists of numbers. We have finite and infinite. So finite means that obviously it has an ending point, and the infinite goes on forever. So notice the differences between these examples. You have a dot, 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 which means that it's continuous. The way we represent each term in the sequence is a sub n. Okay, now that little n or that subscript represents the location or the position of the number that you're talking about. So look at these lists of numbers or the sequence here. Notice the sequence is infinite, dot, dot, dot. Look at the first number. The first number is 1, but underneath it you see a sub 1. That just means that that is the first term. A sub 2, the second term. A sub 3, the third term. And the third term is 7. And so forth, right? So notice that that little subscript represents the position or location. And then some numbers have a pattern, some do not, and we're gonna get into what those are in a second. All right, so let's look at just some examples. So you have all this in your notes once again, remember. I'm gonna switch out my board. So the first example that we're gonna be talking about is finding the first three terms of a sequence. So I'm telling you that the equation or the formula is represented by a sub n is equal to 2n minus 1. Now, given that, how do you actually find the first three terms? So remember, we're talking about a and then sub a position. So if I want the first term, I really want a sub 1. And remember, it's a sub n if you look at the equation. So that means n is equal to 1. So all you need to do is replace n with the number position or the number term that you want. So in this case, it's a sub 1. So I'm going to plug in 1 every time I see n. So 2 times 1 and then minus 1. And I evaluate that. 2 times 1 is 2, minus 1 is 1. I now want my second term, so I want a sub 2. Well, doing the exact same thing, I want 2 times 2 and then minus 1. Evaluating that, I have 4 minus 1, which is 3. The last one would be the third term, which is a sub 3. So I want 2 times 3 and then minus 1. Well, 2 times 3 is 6, and 6 minus 1 is 5. So I have my 3 terms, but I want to go ahead and represent it. So I could either write it as a sequence, 1, 3, 5. I would prefer you actually list what they are. So stating, well, a sub 1 is 1, a sub 2 is 3, and a sub 3 is 5. Those are the 3 terms. What if I asked for the 5th and the 10th term and then of this fraction? Well, that's fine. If I want the 5th term, I really want a sub 5. Now notice the equation is different, but you're still replacing n with 5. All right, so let's do that. We've got 5 over 5 plus 1. And evaluating that, we've got 5 over 6. If I want the 10th term, I want a sub 10. Doing the same thing, I have 10 over 10 plus 1, which is really 10 over 11. So we know that a sub 5 is 5, 6, and then a sub 10, or the 10th term, is 10 11ths. Okay. All right, so let's move on to the next piece then, which talks about series. I'm just gonna go to the notes for a second. So if I'm looking at a series, I notice that I have a different notation. This is called sigma notation. So you notice that epsilon going on over there. There is a button in the calculator for that, but remember, we're gonna try to do this without the use of a calculator. So there are actually 2 different ways that this question is asked. So let me write it down. And sigma notation is really talking about sum. Remember, series is sum. So I'm just writing this out. K equals 1, 5 on top. K squared plus 2. Okay, so represented as a sum of a sequence versus evaluate. Now, evaluate just means find the sum of this. If I want to represent it as a sum of a sequence, right? A sequence is a list of numbers, sum meaning addition sign in between. So let's go through that. So here, if I wanted to evaluate this without the use of a calculator, okay, notice it's telling me K equals 1. 1's going to be our starting point. You start at the bottom. The top number is going to be your ending point. So I want all the values from 1 through 5, but subbed into this equation right there. So first you start off with 1 and you plug in 1 into the equation. Well, 1 squared is 1, and then plus 2 is 3. So I'm just going to write the number 3. I then want everything from 1 through 5. So my next number that I have to place is 2. So I plug in 2. 2 squared is 4, plus 2 is 6. I'm just going to write a 6. I've done 2, now I do 3. 3 squared plus 2, 11. After 3, we have 4. 4 squared, 16, plus 2, 18. So that's 4, and then we have 5. 5 squared, 25, plus 2 is 27. I do not need to plug in 6 because notice that the sigma notation there, the top number is 5, that's the highest number we want to plug in. So now the only other thing is if it says represented as a sum of a sequence, so far I have a sequence, a list of numbers, I need to represent it as a sum by just putting a plus sign in between each of them. And then that would be your answer there. So that's the first way I could ask the question. The second way would be to actually evaluate it. Now, if I asked you to actually evaluate it, you're just adding those numbers together. And when you add those numbers together, you get 65. So it depends on how the question is worded. Okay, so just be careful of that. Going to the next one, just another example of this. So we have another sigma notation, 6 at the top, n equals 1 on the bottom, and it's now of n cubed, okay? So remember, we're plugging in every number from the bottom 1 to the top 6. So plugging in 1, we've got 1 cubed, which is 1, representing it as a sum of a sequence first. Plugging in the next number 2, well, 2 cubed, we know, is 8. 3 cubed, 4 cubed, 5 cubed, and then 6 cubed. So I'm expecting you to know all these cubes. We've had, our chapter on this already. And then representing it as a sum of a sequence. So we're just putting the plus sign in the middle to represent the sum of it. Okay, so the sum of the list of numbers. The last one would be to actually evaluate this. And if you evaluate it, you add them all together, you get 441. So different ways to represent this exact same question. All right, so now we're going to talk about the differences between an arithmetic sequence and a geometric sequence. Sorry, I'm just fixing this little phone clamp thing. There we go. Okay, so first starting with arithmetic sequences. So if we have an arithmetic sequence, noticing it has that add. It has a pattern of adding the same value to determine the consecutive term. So each time there is going to be a pattern of adding the same number to get to the next. So we call this a common difference, or your D value. The way you find your common difference, there is a formula for it. It is D is A2 minus A1. Now remember, the A2 just means the second number minus A1, the first number. Now when you subtract them, so looking at this example, A2 is 31, A1 is 37. Well, if you subtract 31 minus 37, that tells us that we have a common difference of -6. But let's just double check that. So what you want to do, remember, arithmetic is adding. You're going to add that common difference each time to check if that pattern works. 37 plus -6, 31 plus -6, 25 plus -6, and so forth. You want to check it for every single number because sometimes they throw ones at you that do not always work. So that's the first. Arithmetic sequence has a pattern of adding, and it has a common difference known as your D value, which is A2 minus A1. The second type is your geometric sequence. Now, geometric sequence has a pattern of multiplying each time by a certain value, and we call that the common ratio. The common ratio is the formula of R is equal to A2 divided by A1. Second term divided by the first term. Well, if you take the second term in this list here, that is 3, divide that by the first term, which is 9, so you see I do that here, 3 divided by 9 is really 1/3. Well, you want to check to see if that works. Does it actually have this common ratio? So you take the first number, which is 9, and remember it's multiplying, you multiply by that common ratio. Well, is 9 times 1/3 equal to 3? Is 3 times 1/3 equal to 1? Is 1 times 1/3 equal to 1/3? And so forth. And you check it each time. Oops, sorry. So remember, arithmetic is adding. You have a common difference. Geometric is multiplying. You have a common ratio. All right, so now how do we figure out if these are arithmetic or geometric? Okay, so let me pause it for 1 second. I'm just going to write out these. Okay, so are the following sequences arithmetic, geometric, or neither? So we're looking for those patterns, remember. So if we look at the first one, we first want to check to see, is it arithmetic? And the way you find that out is there a common difference? So remember, the common difference formula is D is equal to A2 minus A1. So D is equal to A2 minus A1. Well, if you take your second term, and the second term here is 3/2, and you subtract the first term, which is 1, noticing for this one, 3/2 minus 1, well, this is really 2/2, right, is just equal to 1/2. So D is 1/2. Well, maybe. We need to figure that out, right? So we want to look to see, are you adding that same number each time? So is it plus 1/2. So is 1 plus a half equal to 3/2? Is 3/2 plus 1/2 equal to 2? Well, 3/2 plus 1/2 is equal to 4/2, and 4 divided by 2 is 2. Makes sense, right? Is that plus 1/2 equal to 5/2, and so forth. You want to check all of them. And yes, that works. So since that works, that means that this sequence is arithmetic, and that its common difference is 1/2. The next one would be this one. So we're looking first for a common D value. So D, remember, is A2 minus A1. Well, if we take the second term of 3 and we subtract the first term of 1, D is equal to 2. Maybe. We need to check. So 1 plus 2 is 3. 3 plus 2 is 6. No, that does not work. So it can't be arithmetic. So we now check to see if this is geometric. Well, geometric, remember, is a common ratio. The common ratio is A2 divided by A1. All right, well, the second term is 3 divided by the first term, which is 1, and that means that your common ratio is 3. Okay, well, are you multiplying by 3 each time? 1 times 3 is 3. 3 times 3 is 6. No, right? So since that does not work, this is neither arithmetic or geometric. So we just call it neither. Okay. All right, so that's how you figure out what type of sequence it is. All right, so now let's move on to the next piece. So we're talking about arithmetic for the rest of today. So remember, that's when you have a pattern of adding. So there are 2 different formulas that we're going to be using, and it's the rule for the nth term. How do you actually find the equation of a sequence of numbers? And it's a sub n is equal to a1 plus d times n minus 1. Now remember, a sub 1 is your first term. D is your common difference, and n is just the number term that you're referring to. This is given on your reference table on the regions. However, the second one is not. Sum of a certain number of terms. So if I want to know the sum of however many terms in the sequence, you would use this formula. So it's n, which is the number term, times a sub 1, the first term, plus a sub n, your last term that you're talking about in your sequence, and then divided by 2, and that's equal to your sum. So let's start with finding the rule for the nth term. Okay, so if I want to find the rule for the nth term, here is my sequence. I need to figure out what type of sequence it is first. So I look to see, is there a common difference? Common difference is A2 minus A1, and I sub in. Second term is 9 minus my first term, which is 5. Well, 9 minus 5 is 4. I just want to double check. Are you adding 4 each time? And yes, you are, so that means it's arithmetic. Since it's arithmetic, we're going to plug into the arithmetic equation. A sub n is equal to a sub 1 plus d times n minus 1. A sub 1 is your first term. Well, the first term in the sequence is 5, so we'll plug that in. D is the common difference that you've already found, which was 4, and then times n minus 1. So we're just getting the actual equation of this sequence. So we're going to distribute to get this in the proper form. 4n minus 4, bring down that 5 out in front. And then combining your like terms, a sub n is equal to 4n plus 1. And that's going to be the equation of this sequence. Well, let's double check to see if that works. So if I wanted to double check, let's say, my second term, okay, I want a sub 2. If I want a sub 2, you remember, you're plugging in 2 for your n value. All right, well, 4 times 2 plus 1. 4 times 2 is 8, and 8 plus 1 is 9. So a sub 2 should be 9. My second term should be 9, and it is, so that works. Okay, great. So moving on to the next is finding the common difference. So I'm just going to clean my paper off. Give me 1 second. If I'm finding the common difference here given an equation, right, you're following along in the notes, so you should know what the next question is, even though I don't have it out yet. There are 2 different ways to do it. There's a long way and a short way. So let me just write down the equation. A sub n is equal to 6n plus 3. Okay, so if I think about the common difference has a certain formula. A2 minus A1. But this is all I know. I only know the equation. What I can do is I can find A2 and I can find A1 and I can subtract them. All right, so A sub 2, remember plugging in 2 for n, is 6 times 2 and then plus 3. A sub 1 is 6 times 1 and then plus 3. Right, so you're just going ahead and finding those values. We have 12 plus 3, which is 15, and 6 plus 3, which is 9. If I wanted to plug that into the common difference formula, we should have 15 minus 9. D is equal to 6. So that's the common difference without knowing anything else except for the equation. Now, can you find a shortcut to finding that common difference? Noticing that is actually going to be your coefficient, okay? All right, so the next thing would be finding the 10th term and the 100th term. So just finding a certain number of terms given a sequence. And obviously you can find the pattern and then count, but that would take a while, especially if I asked for the 100th term. So there is an easier way to do it. So I want the 10th term and 100th term. 3, 5, 7, 9, and 11. Okay, so we're starting off with something basic. So what we can do is figure out what is the actual equation to start. Well, we know that each time you want to find a d value if it's arithmetic, and that's 5 minus 3, which is 2. So double check, are you adding 2 each time? And you are, so it's arithmetic, which means we're going to plug into the arithmetic formula. A sub n is a sub 1 plus d times n minus 1. A sub 1, remember, is your first term. The first term there is 3. The common difference is 2, and then I've just got n minus 1. So simplifying this out to actually get the formula or the equation, we've got 2n minus 2, bringing down that plus 3 out in front. A sub n is 2n plus 1. Now that's the actual equation of this sequence. But I want more than that. I want the 10th term. In order to find the 10th term, I really want a sub 10. So you're just plugging in 10 every time you see n. 2 times 10 plus 1. Well, 2 times 10 is 20, and 20 plus 1 is 21. So a sub 10 is 21. The next term I want is 100. So I really want a sub 100. Doing the same thing, I have 2 times 100 plus 1. 200 plus 1, a sub 100 is 201. So another way you can find out different terms in a sequence without having to write them all out, especially if you're given large numbers. And then, almost finished. Find the total number of terms in the sequence. 7, 10, 13, So notice this one is finite. It ends, okay? So we want to know what is the total number of terms in this sequence. So first we need to figure out, well, what type is it? Arithmetic, geometric. So we look for a common difference first. We've got 10 minus 7, which is 3. Are you adding 3? Looks like it. So we're going to plug into our arithmetic. A1 plus d times n minus 1. Now, noticing here, we have A1, which is our first term, which is 7. Common difference is 3. And then we've got n minus 1 plugging in. Now, this time we have an ending point. We know the last number is 55. So a sub n, we're going to plug in for 55 because we're looking for what number term is 55. So let's evaluate this. 3n minus 3 when we distribute that out. Combining like terms, we have 3n plus 4. And now we just want to solve for n. So we could subtract 4 on either side. 51 is 3n, and then finally divide by 3. 51 divided by 3 and is equal to 17. So that tells us that there are 17 terms in this sequence or a list of numbers, and that 17th term, so a sub 17, is 55. All right, so I'm going to post a worksheet for a little practice, and tomorrow we will have an extra help session. I will post when that will be.